So the course objective of this particular subject is we will be studying the fundamentals and transmission characteristic of optical fibers. And then we will study the principles and characteristic of various fiber sources. So what are the various fiber sources? So initially we will be studying the principle, then the characteristic of various sources. Then we will study optical detectors and various fiber optics components. Now here, see what they have done is, they have removed fiber networking from the syllabus, but they have included some various fiber optics components here. So some portion you will study, like what are the components that are used in actual fiber optics communication. So they will introduce the various fiber optics communication. So that we will study over here. Then what we can do is, see, we cannot actually make a whole fiber optic link and all, because it's very difficult to actually lay down a link and practice and all that. So what we will be doing is, we will make a point-to-point link, like from one point to another point. If I am communicating, we will place a fiber optic links and all the components in between, and then we will be calculating that. And that is actually a very important part in any communication, whether it is microwave, satellite. So that is called the link budget analysis. Okay, so that link budget analysis is a part. So this gives you a little bit idea of how, once you know the entire thing, and once I say that you do the link budget analysis of any system, means you know the actual working of that particular system. So you can do the optical link budgeting. So these are the 3 course objectives that we will be dealing with. So let us see what is the course outcome. So as you know, as per Bloom's taxonomy, we have 3 course outcomes. So here in the first course outcome, the students will be able to describe the various theories and principles used in optical transmission using the ray theory and the waveguide transmission theory. Okay, so waveguide transmission theory, little bit you will understand once you study the microwave subject, which will be dealt by Frida ma'am. But this is just like a theory, that is the waveguide transmission theory. But we will be using ray theory of transmission. Okay, basically in my entire module of fiber optics. Okay, so this is just the various theories and principles that you are studying in module 1. Now, once you study all those theories, the second course objective is the students will be able to explain the principle and characteristic of various types of fibers. Now see, when I say fiber optics, fiber is the medium, like you have the RF medium, okay, you have the satellite communication. So fiber is the channel. Okay, so there are different types of fibers. So we will see what are the types of fibers. Then when I talk about sources, there are also various types of sources, advantage, disadvantage. In your design, which source will you select and all. So you should be able to explain all those theories and principles of fibers, sources. Similarly, at the receiver end or destination, you have various detectors. Okay, so you should be able again to explain the principle of detectors. And again, the fiber optics components. Here, when I say various fiber optics components, means there is a mux involved, demux, fiber optics switches, okay, add drop multiplexer. So various fiber optics components are there that we will be seeing. And various methods used in fabrication of fiber. This is important because see, it's not just some people are only into communication side. Some people are actually into the manufacturing side. You people have taken VLSI. Okay, so you know fiber, it's like it occupies very less space. So there are various methods used in fiber fabrication, and as the VLSI technology is progressing, the fiber fabrication methods have improved. Okay, so here earlier we had many fabrication methods that was there in your syllabus, but we have reduced it this time. So you have, people are still coming, some very few 2 or 3 fabrication methods. So we will study that fabrication methods, and then losses in fiber. Okay, so this is very, very important, because once you understand the losses in fiber and you are actually in the technology part, because see, as the generation, like mobile generation has progressed, we are in 4G, and we want to go to 5G, migrate to 5G. Similarly, in fiber optics, when they started, they had the first generation fiber optics. Currently in fiber optics, we say we are already in the 5th generation. Now, what we are doing in these generations of fiber optics, we will see later on, but just I'm telling you, initially when there was fiber, all these fiber components and all were there. Okay, there were no such sophisticated method of fabrication or very good source or detectors. So the losses in fiber were very high. Okay, so the aim was, because from microwave, satellite, coaxial, we came to fiber. So our aim was to reduce the losses, and still we are having the least loss in fiber optics, but still our aim is to reduce, minimize that particular loss. So you have to understand, because the majority of the weightage also, it's not only about CO2, but majority of the weightage also goes on the losses of fiber. Because see, once you understand the losses, then you can think of improving it or reducing it. Okay, so fabrication and losses in fiber. Now, once you have studied all these various theories, what you should do in CO3, that is application. So I should be able to apply the various theories. Like if I tell you, okay, design a fiber optic system for your lab, then what kind of fiber you will select, what kind of source, okay, do I require a multiplexer, demultiplexer? So that is how you select the right component. So that becomes the application level. And why we are doing all this? To improve the receiver performance. So these are your first 3 course objective. The 4th one is, the students will be able to classify and analyze various kinds of fiber, optical sources, detectors, and other components based on their electrical specification. Like if I tell you, I have a single mode fiber and I have a multi-mode fiber, then how do I analyze? Okay, this fiber is good for the particular application that I'm designing, whether in optical source, whether I go for LED or I'll go for laser. Okay, similarly for detectors, whether I go for pin detectors or an avalanche photo detector. So you should be able to analyze those various components based on their electrical specification. The 5th course outcome is, once you have studied everything, you are able to classify, differentiate, compare, you should be able to evaluate various fiber parameters. So here are some numericals we calculate. So what are those fiber parameters? Number of modes. Now what do you mean by number of modes? In a single strand of fiber, when I send one signal, it goes in terms of modes. So there are multi-mode fiber, there are single modes fiber. So various light rays goes through it. So how many light rays will my fiber allow? So we will calculate the number of modes. Then if I talk, okay, I want to improve the losses, then I should be able to first calculate the loss and then try to improve it. Then the quantum efficiency. We don't say just efficiency of the fiber optic system. We use the word quantum efficiency. Then the bit rate error in any communication system, you know, the bit error plays a very important role. And then the non-linearity. Okay, so once you understand all these parameters, then you will be able to calculate the link power budget and the rise time budget. See, again, I'm saying link power budget and rise time budget is very important. The last step, once you design any system, right now it is fiber optics, but in satellite also, in microwave also, we do the link budget analysis, so which gives the power budget and the rise time budget. Okay, so this is my course objective 5. Now the 6th, just see the 6th one. I hope you're paying attention. The student should be able to design an optical fiber communication link. Now this is a very big thing, but usually Bloom's taxonomy says that we are supposed to design an optical fiber communication link. So this for any topographical scenario. So here this is actually very bit impossible because we don't have the proprietary software. So there is a software called as OptiSim. Those who are interested, you can download the student version or free version. They give it usually free for 1 or 2 months. So this semester, if we are going to have only online classes, so I will download it because I'll have the permission for only around 1 month. And in that 1 month, we have to finish all the practicals. But again, the problem comes, we cannot take the exam. So we have to take a plan where we can do it, and then at least you can give the exam. So there you can design an optical fiber communication link. using the appropriate components. Okay, is the course outcome clear, all of you? Please reply. I am like feeling very miserable speaking.
Yes, ma'am.
Yes, ma'am.
Because neither can I see you nor I can scold you, nothing.
Yes,
So,
ma'am.
Yes, ma'am.
okay, so
Yes,
these
ma'am.
are your 6 course objectives. Let us continue. So as per the syllabus, you can see we have 4 theory. As again, this scheme already, you know, we have 2 IA test and semester exams. So 80 marks and then 100 marks. Now see what is, I don't know whether other teachers have told you, since we have started our teaching from 15th July, Principal Ma'am has said that around 15th August, after that week, we will be having our first internal assessment. Okay, so again, obviously that will be online because college will not start. Now, please do that test nicely, because see, like your IA2 last semester, majority of you had a very good score, but we did not consider that IA marks because your first IA was to be considered, but that helped us in giving you your term work marks and your Viva grades. Because see, we have not taken any Viva or nothing. So try to give that IA exam seriously, and obviously the difficulty level will be a bit more because our experience was the score was very good, so it was very easy. तुम लोगों ने शायद कोई Zoom call करके discuss करके किया होगा, what we don't know. There are ways to give that test, but please concentrate on that because this whole semester will go as online only. Okay, so this is your theory examination scheme. Now for your lab scheme, we have practical 2 hours. Okay, term work. So here term work 25 marks, practical and oral exam is 25 marks. So we have a practical exam for this particular subject. So total is 50. So this whole subject carries a weightage of 150 marks. Okay, now practical I won't be discussing much because we have kits in college, plus we do simulation. So 5 practicals, we do hardware kits are there, 3-4 kits are there in our lab. And then we rest of the simulation we do in Scilab, so that our students are very comfortable with Scilab. So that should not be a problem. But after 15 days, we'll get the instruction how the practical is to be conducted. So might be this time it will be all simulation experiment. So we'll see what we can do. Scilab 1 option is there. Okay, OptiSim, that simulation software, if we get the free version, at least for 3 months, we can use that particular version. Okay, so the prerequisite for this subject is physics. You should be knowing the physics concept. Okay, the electromagnetic physics concepts of optics that you should be knowing. Then electromagnetic wave propagation, EDC, that is always there. And since it's a communication subject, so obviously the principles of communication you should be knowing. So the prerequisites are quite easier. So the books, please note down the books, because, and luckily you will get all the books online. So the first book I have highlighted 3, please write it down, maintain a separate notebook. I can tell you to take a screenshot and upload on Moodle. So that becomes an assignment directly. So maintain a separate notebook. Don't feel that teacher nahi hai, koi dekhne wala nahi hai. Okay, so the first book is Optical Fiber Communication by Gerd Kaiser, 4th edition. I don't have it right now in the pen drive, and from Moodle also we were supposed to remove because we are not supposed to upload it. So earlier I had uploaded, but we were told to remove it, and it's in my college desktop. So you try to get this, download this book, you will get it. So Optical Fiber Communication by Gerd Kaiser. Now this is not a direct ebook. It is a scanned ebook. Okay, scanned PDF ebook. And the second book, this you will get an ebook definitely. It's Optical Fiber Communication by John Senior. So these 2 names are very popular. Anybody who will ask you which book you have referred for optical communication, these 2 names should come, Senior and Kaiser. Okay, now this is the new book in the reference book. This has been included. Fiber Optics Communication by Harold Columbus. Okay, so this is the book we are using since last year. First time it was introduced. Now, I'll just tell you, see, this 2 has almost the same topic. Kaiser and Senior, exactly same. But the way in which the block diagram here in Kaiser is there, might be it is little bit different. Okay, so in my notes, what I have done, whichever is the simplest answer of both of them, that is included. Okay, so you refer to this book. My notes you can see directly on Moodle now also. Module 1 ka notes I have unhided it, so you can see module 1 notes. It's entirely digitized, so you can download it, because sometimes if I am taking a test, I might hide it. Okay, so my notes are prepared using these 2 books. Now, what about this third book, which I have highlighted? Module 3 and 4, which I will show you. It is about sources and detectors. Okay, so sources and detectors are there in Kezar and Senior, but during the orientation program, we were told to use Herald Columbus. Now, this Herald Columbus is not there in our DBIT library because the cost of the book is very high, around 22,000 to 23,000. Okay, so we did not purchase it, but an Google book preview is there of this particular author, Columbus. And luckily, whichever chapter we want, in that the Google book preview is there. Okay, so please write down the names of these 3 books in your whichever notebook or diary you are using. So this too you can download from the internet directly, and this you can see a Google book preview. I have made my notes, taken a screenshot or whatever from this Google preview of Herald Columbus. So in my notes, 100% syllabus is there, so you need not worry about what is there. So all the PPTs are also uploaded, notes are there, everything, handwritten notes are also there, and the digitized note, completely digitized notes are there. So please refer to it. Is it clear about the books?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, so let us see the syllabus wise module. So the first chapter is optical fiber and their properties. So it's a 10-hour. This module is, so 10-hour means 10 into 2, so around 22 marks will be the weightage of this first chapter. So what we are going to study in the first chapter is the historical development. Okay, so in the historical development, how the concept of fiber optics came. Then as I have said, there are generations in fiber optics. So what development was made, what invention was, what components was discovered that led to the upgradation of the fiber optics. Okay, so this is the entire history of fiber optics. Then comes the general system. So general system means here we are understanding the block diagram of a fiber optic system. Now, as I have said, we have 2 books, Senior and Kezar. This general system means the block diagram is there in both the books. But if you see Kezar, the block diagram is so big. And in Senior, the block diagram is small. So students feel that मुझे बड़ा वाला draw करने दो तो teacher ज़्यादा marks देंगे. So it is not like that, because for 5 marks, if you sit and draw a very big diagram, a complicated one, you lose your time and then the other question remains unanswered. So we will go for the simplest block diagram. Then obviously, why are we studying this subject? So you need to know advantages and disadvantages. Then the application of optical fiber communication and the concept of optical fiber waveguide. Okay, so this is the first part of the first module. Next comes my ray theory. This you have to understand, student, the ray theory, because as I said, we are not using the waveguide principle so much, but the entire syllabus, the flow, everything depends on your ray theory of transmission. So you should understand what is ray theory. If there is a Viva exam, the examiner will ask you, if a ray is entering, what happens to this? Okay, what is the angle of refraction, and you already know about it because you have studied optics in your lower class, and also in the first year physics, this concept was there. But only that thing is you studied it in the form of a physics, the same terms, everything it is there, but we are applying it to fiber optics. Then there is a concept of cylindrical fibers, only the concept, no derivation, it is already mentioned in the syllabus. Then we have the single mode fiber. Along with it, I am stating we have multi-mode fiber also. Okay, so we will be studying how the single mode fiber looks, what are some equations are there, and the advantage, disadvantage, the properties, single mode fiber as well as multi-mode fiber. Then we will study what is the cutoff wavelength. Okay, and the mode field diameter. So these are the terms associated with the fiber optic. So we will be studying, some equations are there and all. Then the wave guiding principles. So this wave guiding principle and theory of optical wave propagation is little bit related to your microwave, but this does not usually comes in your exam. So we will be covering it in very short because अब तक किसी ने वो पूछा नहीं है, because already microwave you are studying as a separate subject. So fiber optics में वापस से उसका theory पूछने का कोई मतलब नहीं है. So that's why, but it is still there, wave guiding principles and theory of optical wave propagation using the wave guiding principle. The next is the types and classification of optical fiber, loss and bandwidth. Now fiber optics are of various types. हमारे पास glass fiber है, we have plastic fibers, we have single mode, multi-mode fiber. Okay, so how those fibers are classified? Okay, step index fiber, graded index fiber. So we will be studying the types and classification of optical fiber, then the loss and the bandwidth. So this is your first chapter, introduction, 10 hours. Next is the transmission characteristic of optical fiber. So basically यहाँ पे तुम्हारा fiber loss and bandwidth है, that loss actually is present over here. So attenuation is nothing but fiber loss. Okay, so these are the various names of the losses that are stated over here. So attenuation loss, absorption loss, linear and non-linear scattering loss, bending loss, modal dispersion, waveguide dispersion, pulse broadening, dispersion shifted fiber and dispersion flattened fibers. So ये सारे losses hai fibers ke. So you need to understand all those losses. There are some numericals which are based on all these topics. So those are very easy, simple. Okay, then again, coming to fiber losses, there are some non-linearities. So we will be studying the general overview of non-linearities. Then in scattering loss, here we had scattering. So we have again two more types of scattering: stimulated Raman scattering, Brinol scattering. So all these are various losses. Then these topics have been taken from fiber networking. You will not get it directly in Kizar and Senior because it was in a different book. But since I have it in my notes, so what is cell phase modulation? So some modulation methods are there: cross phase modulation, 4-wave mixing and mitigation. So this is some odd man out that they have put over here in the losses, and a new topic, fiber solitons, have been included. So यहाँ पे सिर्फ directly एक short note पूछते हैं, what is fiber soliton? Now once you understand all these losses, in the old syllabus we had methods to measure all these losses. Okay, but here they have reduced it to only two. So you are measuring attenuation loss and dispersion loss. Okay, so the ways to measure it, some formulas will be there, some data will be given to you, and we will tell you to calculate attenuation loss, dispersion loss. यहाँ तक सुनाई दिया?
Ma'am. Yes.
Okay.
Yes, ma'am.
Now see, this
Yes, ma'am.
measurement technique, we have studied all those losses. Abhi dekho, fiber optics, you might have seen on the road, people are digging up, bringing up the fiber optics cable, they are joining something, you might have seen. Now, you, an engineer or a control office is there. So you're sitting in your control office. Okay, so how do you know that at that particular place, a loss is there, a fiber cut is there? Because you cannot dig up the entire length, because 35 kilometers, 100 kilometers tak fiber ka length jata hai. So how do I know that my loss is there sitting in my office, wherever, in a cozy room? So we have a device called as OTDR. Okay, that is optical time domain reflectometer. So this is a costly device which is there, whoever is dealing with fiber optics. So I just send a light through a laser in the fiber. Okay, now what happens is optical time domain reflectometer. Now wherever suppose there is a fiber cut, I'll show you this detailed diagram, but today introductory lecture just I'm telling you. So wherever there is a light cut, so what happens is light reflects from that particular point. Okay, and we calculate the time, kitna time लगता है वो light reflect होने में. Okay, so that's why optical time domain reflectometer. So based on the time taken for the light to reflect from the cut, or there is a bend. Okay, sometimes the fiber bends due to some It might not be cut. Okay, so then we come to know, acha, okay, around 20 kilometers, there is some problem with that particular fiber. So from my office, we travel exactly 20 kilometers and then we dig up and then we do all those things. So OTDR is an instrument which gives you the reading or the measurement of all the losses that you are studying over here. This measurement is the typical measurement. ये हम लोग lab में भी करते हैं, measurement of attenuation and all, वो cable को काट के and all those things, which is a destructive technique. But in actual field, we cannot cut the cable to measure attenuation loss, dispersion loss. So in the field, we use the device called as OTDR. So fiber optics communication is actually incomplete with this. The functioning is incomplete with without this device of optical time domain reflectometer. Okay, so this is something you should remember, that OTDR we will be studying. So in second chapter, we have all the losses, measurement of losses, and the how OTDR works. Next comes the optical sources. So the first two modules you can use either senior or Kizar. The third module, that is the optical source, here you can see the number of hours is 6 hours. So the weightage is very less. So either a 1 mark, 1 10 marks question or 1 5 marks question. 15 marks question isme se aayenge. Okay, so two optical sources which are in use, LED and laser. Even though laser is popular, but still we have to understand the concept of laser, because if I am looking about the cost, then obviously I will go for LED. I will not go for laser. So पहले के syllabus में सिर्फ यहाँ तक था. I understand what are the principle and characteristic working of LED, laser and all. But see, as our generation progressed, many types of lasers came into picture. So in the new syllabus, all these lasers were added. So tunable laser, quantum well laser, charge capture in quantum well laser. Then we have multi-quantum well lasers. So this entire chapter number 3 is from Harold Columbus. You should understand or please remember which chapter from which book. It is not all from the same book. So here no ebooks directly is available. You can see from the Google book preview. Okay, so you type the name. So chapter number 3 and chapter number 4 is available. Then we have the surface emitting laser and vertical cavity surface emitting laser, because all these topics are not even listed in senior and Kizar, because those are the old books before all these inventions were done. Okay, so third chapter from the book of Harold Columbus. The fourth one also 6 hours, almost the same. There you had sources, here you have optical detectors. So working principle and characteristic of detectors, like you have pin detector, APD detector, then what are the material requirement of the resonant cavity enhanced photo detector. Okay, now once you understand this characteristic working principle, then we will be doing the noise analysis. Any system, the noise analysis is important. And we will be seeing the receiver structure, the bit error rate, and the receiver performance. Okay, so this part is a little bit boring because all those theories and little calculations are there, but it was never asked in the exam. That is the irony of the syllabus, but we have to prepare it. So again, this module number 4 is from the book of Harold Columbus. All 4 modules you can prepare from senior or Kizar. Module number 3 and 4 will be from Harold Columbus. The fifth one is your fiber optics component. So this, if you are going in the next semester for fiber networking as an elective, you should understand all these components. So here in the fiber optics components, you will study the fiber fabrication method. So as I had said, there are many fabrication methods, but to keep your syllabus light, we have the vapor axial deposition and the MCVD technique. So there are many such techniques. So we will be studying only these two. The diagrams are a little bit complicated, but you have to draw the diagram. So from this particular topic, you directly get one question of 10 marks, either the VAD or the MCVD technique. Then if I am joining two fibers, how I am joining? So that is fiber joints or fiber connectors. Then splices, there should be a comma over here. Then fiber couplers, multiplexer, filters, fiber grating. Okay, so all those are the components that are used in any communication system. So here, these devices are specific to fiber. Okay, so we will be studying. Now out of this, splices. This is very important. See, when we fabricate a fiber, the length of the fiber is around 2 kilometers to 4 kilometers. Okay, so when I'm laying down the fiber for the entire city, I need to join a fiber. Now you might feel, are fiber joint or connectors hai na? No, those are temporary connection. But if I permanently want to join two fibers, okay, so we have splicing. Okay, here also we have the mechanical splicing and fusion splicing. So this is again a very important topic from the viewpoint of exam. So fabrication का एक topic 10 mark का आता है, splicing का एक आता है. Okay, so splicing is an interesting topic. Every year we used to have a person coming from industry. They used to bring the components and students used to splice that particular fiber, but the actual fiber. But with your batch, we won't be able to have that workshops. It used to be a 4 to 5 hours workshop. So where the person comes with his instruments and all, so they splice a particular fiber. Splicing is basically joining of two fibers. Then we have filters, fiber filters, switches, wavelength converters, amplifiers. Now see, these are not the simple amplifiers that you have studied in your EDC and all. These are all optical amplifiers. So we, in category of optical amplifiers, we will be studying the semiconductor optical amplifier and erbium doped fiber amplifiers. So the component names you know, because it has been used since your EDC time. The names remains the same, but the technology is different. So you need to understand what is the difference. Then only you can go for the manufacturing of those components. So again, this chapter gives, you should understand this, because without this you cannot study the subject of fiber networking. So this is your fiber optics component, weightage 10 to 15 marks or 20 marks, because I said one fabrication और एक splicing का topic रहेगा और एक amplifiers वगैरह कुछ तो पूछ सकते हैं इसमें. Okay, so this is your 5th module. Now the 6th one is your optical link. So as I have been telling this topic, link power budget, rise time budget. This is an important topic. So we are designing a point-to-point link, not point to multi-point. So the simplest design. So point-to-point link we will design. So suppose I tell you, okay, laser लोगे या LED लोगे, photo detector में कौन सा लोगे, whether you select a single mode fiber or a multi-mode fiber, graded index, yeah, step index. So all this comes over here. Then you do the link power budget analysis. Now why I highlighted this particular topic is एक 10 marks का question इसमें से हर साल आता है. Either they ask you a short note, explain point to point link, जो easy है, then you can write many things, or they ask a numerical. It's simply addition and subtraction numerical. So link power budget analysis. So either a short note or a numerical is asked. So we will be doing 2-3 numericals in class, and similarly we will be doing the simulation of one of the numerical. This is the new topic which was introduced last time, that is RF over fiber. Now you are already studying microwave RF. So we are transmitting that RF over fiber. What are the key link parameters that are involved, and radio over fiber links, or the concept of microwave photonics. Okay, see, no technology can remain in isolation. There are already the RF technology, microwave technology there. So we try to incorporate those parameters in my fiber optics. So this is the totally new topic which is introduced. So just like a short note, you can study. So this completes your syllabus, 6 modules. Anybody, any doubt in it? You want to ask? Because I'm not going to start the actual teaching. The actual teaching will start from the next lecture. If you want to share something or whatever.